press / press star. Press return. Stop listening. Okay guys, so this is all of our Arduino code we created in a different IDE. So now we just have to comment out everything that we don't want to put into Arduino. So we redefined all the Arduino defined functions. We redefined them so that we could run it on our Windows desktop with like console out statements instead of digital write statements, for example. Now we're going to comment out all of those functions so that we can copy it into the Arduino IDE and upload it to our microcontroller. And it will work. So commenting out all the functions we made. There we go. Now console out is not defined by Arduino, so we're just gonna Control H, Control R. Wake up. Press / press /. And that's it. That was. Stop listening. That wasn't so bad. It took me like 30 seconds. And I had someone in chat, it was Console Cowboy, that was saying, don't code outside of the Arduino IDE. That's going to take way too long to port it over. Yeah, 30 seconds it took so long. Copy. Alright, open up the Arduino IDE. Open. That's weird. Why does it have to be in a subfolder like that? I don't get it. Anyways, let's just open it. Alright, we pasted in our code. Oh, we also have to comment this out. Missed that part. Adding of headers and stuff. Okay. Now I believe we're good. I think it should all work. Alright. Alright, I'm double checking all the wiring. I don't have it memorized, but I'm just seeing if it looks like everything's plugged in and whatnot. And going somewhere kind of relevant. Everything looks pretty good. Yeah, it looks good. So, let me get out. Here we go. Got that, and this. Okay. Um. Back to our Attiny85 wiring or programming guide. Let's see. To burn the bootloader file, so download the Arduino IDE. Open the IDE. Alright, upload the program to the Arduino that turns it into an Arduino ISP, which means in-circuit or in-serial programmer. Which we've already done to this Arduino. Okay. Adding support for Attiny85 we've already done. Connect the bootloader circuit up to the headers of the Arduino in preparation. We've done that. Uploading program to Attiny85. Okay. Port is COM5. I'm happy with that, sure. Looks right. Select the proper COM port, did that. Okay, next go to Tools, Burn Bootloader. Okay. No, we don't want to do that. I've already done that. After booting the bootloader in this fashion, theoretically you could connect this device via micro USB to the computer and upload sketches to it. However, this device does not have USB converter chips, so it can never communicate directly with the computer. So around this, you will want to upload sketches using the same wiring diagram as we used to install the bootloader, and once a sketch has been uploaded, unplug the Attiny85 and plug it in. Okay. String does not name a type. What? That's really interesting. You can't do strings, huh? Done uploading. Okay. It flashed violently during the upload process. Alright. Well, let me just get this unplugged then for the moment. And we have now our program on this Attiny85 here. So the next step will be to breadboard our desired circuit that we wish to use. For our printer. Let's see. So, pin 0 is our PWM pin. Got it? Okay. LED is pin 1. Alright, let's connect the LED circuit up first. So, we're gonna want, let's go with yellow. You know what? I kind of think now would be the perfect time to start using these bad boys. We got these cool jumper wires here. Should be different. You know what? Maybe I'll jump to that when I want to clean up the wiring. I don't know. It seems like a pain to try to figure out what length we want. I think it's easier just to grab something generic. Alright, so let's do yellow for LED. We have a yellow LED anyways. I'll try to get you guys closer. Well, wait a minute. I mean, maybe that's not even the answer. Maybe this is the answer. Alright, so you guys can see real nice now. Get this LED out of here. We're just gonna set it aside for now. Okay. So, the LED is pin 1. So this is now connected to pin 1. And I say we'll move the LED somewhere out here. So power's going out to it. It will get... Wait. So there's the power, and then the short pin goes to positive, long one goes to ground. So the LED has power now. When that pin turns on, that is. And then this resistor will connect to the LED. Okay. The resistor will then connect to ground. So now this ground is ready to head back to the ground of the Attiny Microcontroller, which is here. Boom. Okay. So that LED is all rigged up now. What do we want next? So that LED will come on, according to my programming, only when the solenoid sends a signal to solenoid signal read-in pin 2. Alright, so pin 2 Pin 2 will have red go to it and black go to it. Get out a red and black if I can find it. Alright, here's a black one. Alright. So, pin 2 is here. Okay, got it. Making sure that's plugged in all the way it is. Alright, so pin 2, wait. No. What the heck? Close window. Stop listening. this black one has to go to ground. Huh. This is sketchy. Alright, so this black one goes to ground. It's going off to our solenoid. We need a red one to go to the solenoid. Can I get a red? Here we go, here's a red. Okay. Bingo. The red one is what goes to the digital input pin 2. Actually, it shouldn't be red, should it? Technically it's for power, but it's not like a power rail, it's a signal power. So let's go with orange instead. I like to differentiate. Like the power coming from a power supply versus just a signal. Signal's always going to be power plus, but can't have every signal line be red. Could even do white, in fact. I'm trying to figure out my coloring conventions. I always knew, yeah, I pretty much guess it's going to be like black for ground, and then red for like main power line coming in. And then all the signal lines, which are technically power, will be yellow, white, orange, etc. Okay, so signal for pin 2 is now ready. Okay. What do we want next? Maybe this should be over here. Okay, so it'll have power. It's got its LED. It'll get the signal there. Signal connects to the voltage divider, which connects to the 24 volt line. What else do I need? Well, I mean, only one more cord comes off it, and that goes to the motor, right? Signal in, motor out. Okay, let's do that then. So that would be... I'm cool with it being a... You know what? Let's go with white to the motor. Do white and black for that. Because we haven't used white. I was going to use orange for the motor, but we already used orange for signal. We have so many colors to choose from, why not, like, differentiate as much as possible? Okay. So, and then the motor pin is, which one? Motor MOSFET PWM pin 0. Pin 0 is the motor. Got it. Okay. Motor output is there. And then, oh no. Well, wait, let's first get the black for the motor. Okay. So this is the motor's ground. Put that on the ground pin. Alright. Now, we're not supposed to connect to the motor directly. Oh my. You know what? I don't even think. Is there any reason why we're even breadboarding this? Well, we can run. Grr. Oh, I know. Instead of a motor, we'll just connect it to another LED, maybe. Ugh. Or not. We just have it connected to nothing, because we got the LED indicating that it's going to do the cycle thing. If we plug it in, ha! I know what to do. We'll plug in the Arduino and use that to send the 5-volt signal. Duh. Wait, will that work? No, it has to go through a resistor first. I equals V divided by R. 5 divided by 5, if we did a 5 ohm resistor. Well, let's say it was a 200 ohm resistor. 5 divided by 200. .02 amps, which is what? .25 milliamps? I don't know, I have to go to my voltage divider notes. No, that's not it. Switch mode power supply. Alright, a 1000 ohm resistor would give us 5 milliamps. So let's get one of those out. That'll work. 1000 ohms we're going to use for we're sending a 5 volt signal from the Arduino to the solenoid signal pin to fake as if the solenoid just turned on, to simulate that. Alright, 1000 ohm resistor is here. Okay. And we will put the 1000 ohm resistor, let's see. So our signal line was here. So we'll put that, let's say right here. Right here is good. Alright. And then we'll put this between that line and the line next to it. And then the signal ground will attach to the Arduino ground. Okay. Good. And then the Arduino can have, let's say, yellow wire going from, let's not get something that long. Okay. Yellow wire from Arduino over to that signal in. Like so. Let's put it on the 3.3 volt, I guess. That'll still send a high signal. Alright. You know what, that's kind of tight, but I guess that's fine. So that completes that circuit. And then to power the Arduino, I have a creative way to do that. I'm going to use blue. I'm going to power it from the Attiny. Okay. So blue will come. Wait, that's not going to work. Wait, 5 volts. Actually can work. Okay. Arduino's got power now. I don't like how taut this yellow one is. Let me get something longer for the yellow one. There. Alright, and this is going from 3.3 volts on the Arduino to close window. Stop listening. To solenoid signal fake line. Okay. So the Arduino's got power. I'm going to get rid of this white line, which is supposed to go to the motor, because we're just not going to do that part right now. Let's see. This was the ground for the motor. We'll get rid of that too. Oh, chill out, everyone. Okay. And I'll put those back in neatly to my wire harness stack thing. Wire bundle. Alright. So what's going to happen when we plug in the Attiny is it's going to send power to the Arduino through the blue line, which is connected to the Attiny's 5 volts. The blue line will run over to right here, go into this red line, and the red line will go into the Arduino's 5 volt line, which will turn on the Arduino. So that will have power. Then from the Arduino's 3.3 volt line, it's going to send power to here through a resistor, 1000 ohm resistor, and then into this orange line, which will then come over to pin 2. Pin 2 is the pin that we read when that signal goes high on pin 2. That triggers the Attiny to turn on the motor turning sequence, because that would mean that the solenoid was triggered, which is part of the laser printer's process of kickstarting a print job. So pin 2, we're going to have manually the ability to unplug and plug this into 3.3 volts on the Arduino, and each time we manually plug that in, pin 2 will go high. And when pin 2 goes high, the Arduino says, oh, it's time to turn the motor. And whenever it says that, it turns on this LED, which is rigged up to pin 1. Pin 0 is the motor, pin 1 is the LED. Pin 1 is this yellow wire which goes over to the LED, which then goes into a resistor, 220 ohm resistor, which then goes into ground. And this black one's the ground, and that goes to the ground of the Attiny85. So everything looks right. The Arduino has power and ground coming off the Attiny, so it will be live. By default we have it switched on. I would like by default for it to be switched off as far as the 3.3 volt signal. So when we first start out, this LED will be off. When we plug this in, this LED will be on. And what else? If that LED comes on when we plug in this right here into the Arduino, which is like a pretend scenario of the solenoid just came on. If this LED goes on, we know that the Attiny code is working, and we know that it would then turn the motor with pulse width modulation. We're not setting up the motor right now because why? Well, let's see. That'd go from pin 0 to a bunch of stuff would be happening. Now that could be a big mistake not to set up the motor actually. Should we set up the motor and the breadboard? Heck yeah, we should, I think. You know what? We could set up a LED instead of a motor. But I guess I just felt like there's no point, like... Yeah, let's just skip it. We'll know everything's working without having to go to that part of things. Where the heck is my... Oh, here it is. Okay, let's get it. Oh my gosh. Oof. Oh. Alright, when I plug this in, the Arduino's going to come on and the Attiny is going to come on. But this LED should not be on. Everything will be good. It's going to be in a waiting state, waiting for pin 1 to go live. And that's it. I trust this. Okay. No magic smoke. The Arduino appears on. This LED is off, just as we suspected. Everything looks good. If I plug this in, the Attiny is going to think that the solenoid just went off and it's going to turn on this light for 1.5 seconds. Then it will turn it off for 200 milliseconds, then it's going to turn it on again for 1.5 seconds. So it'll just be blinking pretty much. So let's go ahead and get that going. 3.3 volts is not turning it high? Now it's time to troubleshoot because it's not working. I wonder what's going on. All the wiring looks right to me. Unless the LED's in backwards like last time. Alright. I have something else I want to test. Maybe it needs a full 5 volts before it will register something as having gone on. Maybe 3.3 wasn't cutting it. So I'm going to plug this into 5 volts. Nothing. So basically, I'm looking to create a third pin that will just blink every time the while loop is successfully indicating it's running. Because right now, everything's just dead, nothing's happening, so we just don't know what's going on. Could it be the int main? Yeah, maybe it's the int main. Oh, it could be that. Uh, I bet it is. Bet you it is. Heck, even that would help. Let's just have it turn on pin 3, which at least tell me that something's going on. Because right now we're dead in the water. I mean, we have absolutely no sign of life. Alright, so the next step, we're going to unplug. Alright, so now it's off. We're gonna pull that out, pull that out, pull that out. Alright, we're gonna pull this out. We're gonna reprogram it. I'm gonna put that in here. Alright. We're gonna move this one out of the way. Okay. And getting our programming circuit set back up now. Okay. What the heck? Alright, so power to power, ground to ground, reset switch to lead acid, and then, not lead acid, yeah, lead acid, and then back to ground, okay. The 4 signals to the 4 signals, got it. Everything looks good here. Let's try to program it again. It might not have even taken the programming the first time, actually. It looked like the reset switch was plugged into the wrong one. So maybe that's what happened. In which case, I think it would just be blink program. Might have still had blink program on pin 0 that whole time. No, we connected pin 0 to the LED, so it didn't even have that. I don't know what it had. Or it could have been the void loop issue. I'm not sure. Well, we're about to find out what's next going on. Now it's error compiling. What's wrong? So far, everything's a comment to here. Handful of booleans. The only thing we changed is this. A new int. Uh, oh, maybe it's the placement of int main comment? Okay, let's try that. Okay. Let me try that. What's wrong with it? Oh. Let's try int main? That's weird, it only took int main. Done uploading, weird. Stop listening. Stop listening. Alright, well, int main is fine with me. I'd rather not do void loop anyways. It's just weird it wouldn't take void loop all of a sudden. Alright, so now I can unplug this. And the only difference then that we put in is pin 3 will just turn on, period. That's the only thing. Everything else is all stock. Also, we might have had an issue with programming it the first time to begin with, due to that reset button thing. So that could have just been a corruption? Possibility? Alright, we got problems here. I can't get this board out. because things are too close. So let me just move everything over 3. Okay, you guys move left 3. Okay, and get you over to here. Okay, pin 2 is our go time signal. And now I can plug you back in. Okay. Get this ground plugged back in. Alright. Honestly, I'd rather just use this LED for... Let's see, what do we have? We have the board? It goes... Okay. This one, this blue line, isn't connected to anything. Okay, this isn't connected to anything. If we plugged it in right now, nothing's connected to anything. Nothing should happen. I'm cool with that. I just want to plug it in real quick. Alright, so we got the status LED. Nothing should be happening. It's not getting any signals, nothing. Okay. Now, this one should have switched on though. Not pin 0, pin 3 should switch on. I need a wire to do that part. Let me just do green. Green will mean things are good. Or no. Do we have green? Yeah, here's a green one. Alright, so green was switched on if the main while loop was entered properly. Which should have been instant. We can connect that up to our LED. And the LED should come on. And that will mean good things. What? What is this guy even doing? That's weird. That's super weird, guys. Pin 3, 100%. All I did is came in here and did pin 3 to 1, which means on, high. And that didn't work. And that didn't change either, it's just set to 1. Let me do a voltage test, but I'm guessing my formatting's wrong. You might need void setup for anything to happen. Okay. I don't even know why I'm using the multimeter. Okay, that pin 3 is not on, period. Which tells me I don't even think it's running my code at all. Okay. Ready to run another test. So it's back to... So far we've had nothing work. Nothing at all. It's not that funny, but I think it was int main. I read on a forum post you can use int main. Now I'm starting to doubt it. I think that just nothing will work if you use int main. That's my new hypothesis. Everything could just instantly start working now. Any of these little changes, we're going to learn something for sure. Because there's something we don't know that's throwing off everything else right now. Okay, so we just get this connected up to power. And this connected up to ground. Signals are all wired up. Yes, everything looks good. Huh. Okay. Let me just get this connected then. Bam. Very nice. And let me upload it. What the heck is flashing? I don't know why the Attiny is flashing its butt off now, but that's definitely a change. Hopefully we're in business now. Pin 2. Okay. Green to pin 3. Pin 3 to our LED. LED to ground through resistor. Ground to ground. Okay. And I think that might be it. Oh. Okay. So that's pin 0 is connected to nothing. pin 2 is connected to nothing. Pin 3 is connected to LED, which is connected to ground through resistor. Alright, so pin 3 should turn on if everything's working, and the LED should turn on. That's all we know for now. So let's go ahead and try it. No LED? What the heck? I'm freaking lost. So far nothing has worked at all. Alright, so we need a baseline of something that works. Hi Queen. Hi Gund. Hi Wambra. Hi Tommy. Yes. Well no. Not really. I'm using an Attiny85 board and an Arduino board to program it. Alright. So this has been a disaster. We gotta come back to the basics. Let's start off with blink. Go from there. So many assumptions are untested. I've just got to troubleshoot what the heck's going on. It's down to troubleshooting at this point. Something's very wrong. Alright, so I commented out all of my code. We're going to get the blink program running, and then we'll slowly reintroduce my code little by little. Heck, I'm even going to comment out, well, no, I can leave my variable declarations, I think. Should be fine. It's just integers and Boolean declarations. That shouldn't make a difference. Come on. Alright, for this, we're going to do pin 3. That should do our blink. Alright. That's blink. So let me stop listening. Let me come in here now for the millionth time. This is a real pain in the butt. Switch it back to our programming circuit. Okay. And pop this here. Five volts here. And ground here. Everything looks good. Plugging it in. Boom. Alright. Upload sketch. Sketch is done. It's no longer doing that weird blinking. That's good. Alright. Unplug. Very good. Get that out. Alright, has blink program on it. The nice thing about doing it this way is you rule out so much stuff and just add in one thing at a time, and it's just yes or no. It's very binary. Just did it work now? Did it work now? So you can slowly start adding in complexity. But you have some type of baseline functionality so that each thing you add in can only be it worked or not. So it rules out things very quickly. Alright. I'm just going to plug it in. It should blink on pin 3. Whoops. That's all messed up. Pin 3. Lined up there. Okay, so pin 3 should blink. And we need ground connected. I kind of feel like plugging that in later. I feel like plugging it in now and it's not doing anything. Okay, status is on. Now we connect this to ground. And that damn thing hopefully will blink. Alright. What the hell? Alright, I'm gonna see if that LED turns on if we connect it direct to frickin' 5 volts. What the heck is going on? Maybe the LED's bad? I don't know. Oh, come on, it's still... Dude. Is it the LED? What kind of robot are you making? Type in exclamation mark goal to find out. Alright, I got an idea. This told me a lot actually, guys. It told me that everything is in question right now. It told me that this LED is broken? The frick? If the LED's broken, and we've been basing everything we think we know off that, then... None of these wires matter except... All these wires are from previous tests. Except for 2 wires. So, you guys could be seeing a lot of wires that aren't plugged in anymore. It's because we simplified things down to just trying to run a blink program. Because we're trying to find out why this LED won't start up. And it's beginning to become apparent to me now. Let's run a resistor test. This should be a 220 ohm resistor. Okay, what the hell is going on? It says it's 1,000,000 ohms. It's a 220 ohm resistor. Why is it saying it's 1,000,000 ohms? Okay, I'm so incredibly confused. This is the weirdest thing ever, man. Why is everything acting so stupid right now? None of this makes any sense. $220 ohms, okay. Good, something made sense. Alright, let me stick this into ground. And I'll stick this one into here. $4.7 volts. Okay. I'm gonna put this guy right here. Let me get a different LED. I don't want to move that one because it might be broke. Oh my gosh. Oh my gosh. I need to calm down. I just went to set this thing down and I put it gently on my keyboard, but magically it has enough weight to press the spacebar key 1,000,000 times. Okay. Okay. Need a LED. Somehow, maybe that LED died. I don't know how. $1,000,000 ohms is infinite resistance, so it's not dangerous at all. Okay. So we can put this into here like this. And it's gone. Where'd it go? If an LED doesn't turn on and your entire testing revolves around that, then what do you expect? That's a false positive. I'm like questioning everything, questioning my coding, questioning all this stuff, and it might have just been a bad LED the whole time. I mean, there's just so little for me to go by. What the heck? Okay. Now let me get my ground pin. What? That didn't work? This makes no sense at all. Come on! What the heck? Oh my gosh! I am about to lose my mind right now. This should be on. This is a new LED. What's going on? I'm so confused right now. I can't even get Blink program to work anymore. I don't know what's wrong. This is the most annoying thing ever. Hell yeah. What in the hell is going on? We got an LED to work, guys. This is weird, though. This side, the long pin wants to go to positive. What the frick? Both LEDs are working? Alright, we got a start to a win going on here. Okay, Blink is working. Let me just bask in this moment. Something is working! Yay! I haven't learned crap though. Alright, I just gotta keep on going at this. We're nowhere near a pausing point or a stopping point, even though I'm tired as heck. This doesn't really get us anywhere. Alright, let me come into code now and focus on coding for a bit. Also, let me close the LED bag before it falls everywhere. Falls and gets them everywhere. Okay. Let's go with pin. Wait. Stop listening. First things first, let's get rid of all these stupid comments. What experiment do we want to do first is the question. Well, let's keep everything the same except let's try to use a variable for pin 3 instead. Like this integer. And just to make sure our new program actually is our new program, instead of a 1 second on, 1 second off, let's go 5 seconds on. So it'll be a lot slower. So what we're proving here is that the new code went in by the 5 seconds on. We're also proving that a variable can be used instead of writing 3 for the pin. I know that should be the case, but I'm trying to get rid of a lot of assumptions because I made too many and I got in trouble before. So let me go ahead now and run that, and we'll just baby step our way through it. So, same pin, same everything will be used. Okay, power's gone. And get rid of that. Get that off. Okay, we're still going to be using pin 3. We change the blink speed. Okay. And get that here. Get this plugged in. Like that. give you power and give you ground. That. And we should be good. Power and ground are in, all that's good. Okay. Verify it. Upload it. Oh. Okay. Forgot to plug in. Oops. Alright. Upload it. Done uploading. Okay. Pop that back out. Pop that out. Boom. I left power and ground on the Arduino. I don't want that. Never mind. Let me just get that there. Okay. So. If we plug this in to pin 3, blank should all work, but it should work a lot slower if everything went according to plan. And we'll have verified that a variable does in fact work instead of writing the pin name, which I believe it does, but we're not assuming anything. We're just making little baby steps, little wins here. Okay. So all I have to do is plug this in, and it should be blinking slow. So just showing that our workflow works, that we have responsiveness. What the actual crap? Are you kidding me? Oh. False alarm. Good. Alright, everything's working. It worked. So, we verified that variables work. Good. What next? Alright. 5 volts and ground. Plugged in. Is everyone else good? Positions, please. Okay. Everything looks solid. And let's go back to coding mode. Now, what else do we want to debunk? I want to debunk that high and low can be 1 or 0. Verify that that actually works. Done compiling. Okay, so compiled without errors. I'm going to plug it in. I'm going to run the sketch. Oh, except to make sure it's working now, we want to go back to it running 1 second intervals again. Okay, it compiles fine. Plug it in. Done uploading. Okay. Unplug. If I'm not mistaken, we could unplug just these two and plug in pin 3. Leave the Arduino communications pins in, leave that as is, everything's fine. And then plug this into ground. This will really speed up my workflow. Good. That into ground, and then we're just going to plug in power. So we don't have to keep moving the whole board. That's awesome. That's what we needed. Okay. So let me just connect it up. Boom. 1 second intervals. Perfect. Alright, so that proved that 1 and 0 instead of high and low does in fact work. We're having to prove everything again. Baby steps. Okay. Now, get rid of this. Okay. And we'll get rid of this. Okay. Plug back in the programming circuit. $5 volts and ground. Like that. Alright. What else do we want to now prove? Well, I think it'd be fun to see what happens if we declare pin mode not under void setup. Okay, so we still have void setup here, but what I'm proposing is we take this out, initiate pin modes equals true, and that's defaulting to true. Okay. Void loop, initiate pin modes will run once. It will declare that as an output pin. And then it will do its thing. So this will prove that void setup is not needed, and that just an if statement that runs once can be tossed into the loop, and that can declare things. And then we can just go straight into the blink program again. I think this is a great test. So let's run that test. First we got to make sure our programming circuit's set up. So that looks good, that looks good. What the heck? Okay. Let's plug it in. It's plugged in. Upload it. Done uploading. Okay. Wait. Well, stop listening. It'll have still the 1 second blinking. Nope, that's not acceptable to me. I want a 5 second blinking. Done uploading, okay. Let's give it a look. Unplug these. Well, I can just unplug the red one actually. Coming up with all the little tricks. Okay. Unplug red. And plug green into pin 3. Okay. Plug black into here. Beautiful. Give it power, and it should blink at the 5 second rate, provided that everything worked okay with the code. What? That's not blinking. It's just staying on. That's a red flag. Okay, so the only place that you can name a register pin is inside void setup? And that's non-negotiable? be darned. That was very important information to know. Okay. That's huge. Alright, that's big, big. Big, big, big. Ugh. Can I assume that was our only error? Alright, so we're commenting out our main while loop now. And the reason we couldn't use void loop before is we still had return 0. I forgot about that. Which I commented out now right here. So void loop should run. Everything inside this while loop should not run. Void loop no longer has return 0, so it won't throw that weird error. And set a bookmark. Okay. So it should just blink once per second. Initiate pin modes was the worst thing. That does not work. We were able to verify that earlier. Okay, so we undeclared that. And we need to undeclare this as well. Initiate pin modes completed. Okay, that's undeclared. Now we can delete that whole section. That was a failed experiment. We always have to initiate pins with void setup. It's very important. But void loop is still on the fence. We might be able to get it with int main instead of void loop, but we don't know yet. And then all the rest of this I'm fine. Initiating pin modes completed, we took out. So it would be these two both being true when they're first declared. Whoa. This needs to be undeclared. Okay. Let's undeclare this one. Alright, getting rid of it. And then this one, let's make sure it's undeclared. Alright, so we can get rid of these. This will initialize to true. Okay. Beautiful. Save it. Alright, so none of this is going to run though. It's just going to do the void loop. We just made a couple quick changes. I just want to go ahead and run this in Arduino, upload it, get our blink working again. And then we're going to do the int main test. We'll see if int main with return 0 and then while this is true actually works. But we'll just have this stuff not run. We'll break this. Maybe initiate this to false instead. And we'll just have the blink inside here. And that will show whether int main or not works. So let me just copy it. Pasted it. Beautiful. So let me get ourselves set up. Let me unplug the Attiny first. Beautiful. And we'll get Blink unplugged. Does it actually matter if this is connected? No. We don't have to touch the green one. Nice! See, we're getting this dialed in, man. Saving ourselves steps. Okay. Close this bag. And we just need the power plug connected. Okay, that goes here. Beautiful. All the communications are in, all that's in. Good. Good, good, good. Good. Okay. Alright. We're ready to program it. Let me plug in our circuit. Alright. Uploading now. Uploading done. Unplug it. Alright, so all we have to do is unplug red. That could be easier to unplug this one. Alright. Unplug red. Plug in black. Let me tuck red and black in further. Okay. Then this black can plug in easier. Good. Now I can plug in the AT-Tiny. It's connected to the blink pin. It should blink at 1 second interval. Off pin 3. It is not connected to Arduino with power. So Arduino's powered down. It has no power supply. So it won't affect anything. And we're good. 1 second interval we're expecting. What the heck? Uh-oh. That's not good. It's not working properly. Just turned on the LED, but it's not blinking it. These aren't scissors, these are surgical pliers. Something's wrong. It's not blinking the LED, it just turned it on. How is that even possible? Something's wrong. What the heck? Alright. Everything's broken again. So we're back to troubleshooting here. We were supposed to be doing a baseline standard test and everything was supposed to be fine. Output pin 3 is the only pin mode we're going to declare now under void setup. And maybe you can't have an if statement under void setup. Maybe that's throwing everything off. We don't even know, but we're just going to do it how it is. Everything's commented out below this point. Everything. So it should run fine. If it doesn't, then we even gotta get rid of that if statement. That's the only thing that could be the culprit. But we're trying to figure out what's wrong now. So it's void setup, and then this tiny little loop. That's it. It should blink fine. So let me connect up that, and we'll go from there. Alright. So let me unplug it first. Okay. And get rid of this black one. Okay. And we'll plug back in red. Like so. Boom. Okay. Done uploading. Unplug that. Unplug red. Plug in black. Plug in this. Should work. No, doesn't work. That is truly baffling. It's not blinking. Alright, so that the only thing it could be, I think, is this. Unless if I'm just completely losing my mind. Alright, everything's commented out except pin mode and void setup. Void loop, and then just a big comment below it, pretty much. This void loop is just a basic blink program, so I don't see how that could be the fault. So if it was this if statement corrupting it, I don't know. But we should be good. So let's run this. Alright, as fast as we can. We gotta go through iterations quickly. Okay, so that's gone. This has to go back in. And this one comes out. This one goes in. Uploading. Done uploading. Okay, this one comes out. Unless if we're not even coding it right now. Unless if these programs aren't even going through and we think they are. Unplug red. Plug in black. Okay. Plug in this. It should work. No. What the actual Nikes? Oh! Nothing. It's just blink right now. Could it be int main being on the same line as this, maybe? Void loop. I'll just get rid of all of this. Void setup and void loop. Now this is just stock. This better work. Floof, I don't know what you're talking about. You're putting star // I don't even know what that means. You need to be more clear if you're trying to give me advice right now. Okay. Get that out. This in. Okay. That's in. Uploading. Done uploading. Pop it out. Pop this out. Pop this in. Pop this in. Still not blinking. What the fuck? That's not possible. This is just stock blink program now. Alright, I'm pasting in the blink program then. This is so weird. Alright, I'm gonna run that. Not blinking. The stock blink program is not blinking. It's not my code's fault. This thing's not getting new code. How could it not be getting the new code? Okay, I got it. I figured out what's wrong. It's a hardware issue. It's not... Well, maybe... I'm guessing. Can't sound that confident. I could be wrong. But... when we program it... I want to unplug everything from my other circuit. We were starting to get lazy, I think. Certain things might need to be removed for it to send the code over. I'm thinking it's not even getting the code. Yeah, I don't think it's getting the code at all. I think the Arduino's sending the code, but it's not getting it. The Arduino thinks it uploaded the code, but that thing didn't get it. So we haven't been sending it code updates for a while now. That's the bottom line. And if you're not sending it code updates and you're making changes to your code and it's not working, you're going to keep making more and more changes to your code. And since it's not changing the code actually in it, but you think it is, then you're thinking something's wrong with your code and it has nothing to do with your code. It's not getting the new code, period. That's my worst nightmare when you're troubleshooting. It has to get your new code each time because I'm supposed to be learning from each thing. Okay. Good. So that was it. You have to unplug this and unplug this fully, and then it will run new programs. Got it. You cannot have pin 3 plugged in at all. It has to be empty. Even though it was just going to a LED, to a resistor, to nothing. for some reason, that caused it to fail. Huh. Well, that's weird. It fails if we don't leave power and ground plugged into this Arduino. I plugged this power pin back into this Arduino, and then it started working. What the actual crap? That is so weird. So we don't unplug this power pin for anything now. Huh. That is mind-blowing. I don't even know what the connection is, why that would be. That's just awful. Awful stuff. Unimaginable unimaginable cruelty. that something so random could be the cause. Had nothing to do with my code. Look at that. We just made it blink with the 1-second pulse mode. So we're actually running live programming on it and live tests without even unplugging the Arduino now? What the crap? That's weird. I didn't expect to do things that way. So it's actually running right now while being connected to the Arduino. Huh. Well, that's faster. Way faster. I don't even have to unplug anything, you're telling me? Okay, so it's got power from the Arduino. It's all set up to program from the Arduino. This is weird. Huh. Well, I don't have to like it. I just have to use it. Now we can get to the bottom of things. Alright. So this can, I think, be uncommented. Minus the console out statement. This can be uncommented. From the top now. Really feel like we'll be okay now, hopefully. I found so many little quirks. Weird stuff happening. But we troubleshooted our way through it. We found the oddities. Wake up. Press delete. Press return. Press 5. It's working. Stop listening. That's hilarious, man. We don't have to change anything but the code and we're getting results. All the wiring's the same, this thing just works. That is badass. All that plugging in, unplugging, plugging in, unplugging, that was what was slowing me down. We can run through code iterations as fast as we can code now. That's great. Okay, so having the if statement within void setup was not a problem. Having all these declared was not a problem. We just verified it. Int main being commented out here was not a problem. Now I want to know if int main being commented out right here is a problem. Not a problem. Wonderful. Man, we're gonna fly now. What did I want to check next? Man, this is exciting as heck. Well, what would happen if I did this? It wouldn't loop, but could it run once? Uh, it's just the light being on. That's weird. Okay, weird. Now it's back to working normal, which you can see here. Okay. Let me move it up a little higher to center frame it. Alright. My next test will be that's nice to know though that you can put int main just right below it like that. Alright, so we're not gonna do int main anymore. Only if we're doing the desktop version. So that's settled. Alright, if we're in void loop. Okay. While false. Okay, let's see if this works. Yep, it's still blinking. Okay. Then oh. While run program equals true inside void loop would be 2 loops. The first loop doesn't mean anything though. It's just the loop containing the other loop. That would be okay with me. I wonder if it's okay with it. Check 5 volt. Wait, check for 5 volt signal. Run program equals true is defaulting to true. So it will void setup, do all the pins, void loop, do run program equals true. It will not enter this, so it won't be able to enter anything else. None of this will get set off. So it will just run the loop doing that. Alright, let's bump it up to 5. And run it. Ooh, look at that. 5 seconds on, 1 off. 5 seconds on, 1 off. There we go, it worked. Okay, so having a while loop, the main while loop of our program, inside of the void loop instead of int main works. They're happy with that. Alright, let me see what would happen if I did int main and return 0. I bet it'd break it, but I just want to verify for sure that int main's not going to work ever again. And with int main, I guess I'll add the return 0 back in. I broke it. Return 0's off. Maybe with return 0 off, but int main. We'll try it again like that. Still broke. Okay, so int main is 100%. 100% not acceptable for Arduino. Got it. I mean, I literally read on a forum it's okay to use int main for Arduino. That was just factually incorrect 100%. I just proved it. So int main's out for sure forever. Anytime we want to port our code from our other IDE into Arduino, we have to get rid of int main, comment it out, and put in void loop instead. Got it. So these are hard rules. Let me make sure all this code is up to date with these new hard rules. Void setup, good. Void loop, is that what it's supposed to say? Void loop. Int main could be above it or next to it. I think above it's good. And then, yeah, that would all work. Okay. Now what? Oh? I want to get my blinking going again. Just run it. Alright, blinking's going normal again. Which is just fun to see. Okay. Where were we? So, I can get rid of that. I got an idea. Wake up. Caps on. Just do basic blink. Press J. Press delete. Press delete. Press delete. Alright, let me run that. Alright, it worked. Stop listening. So now we can toggle just this one variable to go into basic blink mode. Let's put that to false. Wake up. False. Press F. Stop listening. So with that false, this will come in. Checker 5-volt signal. That's defaulting to true, so it will pass into here. And wait a minute. If we ran it right now, just do blink is off. Um, Alright, so this is going to spam wait for a signal to come. It has a couple output pins that can do stuff, but none of them are connected to anything. So, just the one it's connected to, which is pin 3, it is going to turn on and then turn off for 5 seconds. It's going to spend most of its time off. We're going to have to put a delay after 1000. Alright, so it'll come on for 5 seconds, then shut off. Each time between queries of whether it's getting that 5-volt signal from the solenoid. Which is supposed to be coming in on pin 2, I believe. Alright, let's run it. It should blink 5-second blinks. What the hell? It's doing something very unexpected right now. The LED is not flashing. Pin 3 is not doing anything. That was the LED. That's just off, and instead something on the little Arduino board is flashing, which is, or the little Attiny board is flashing. You guys can see it a little bit. So that's weird as heck. Alright, I want to go back to something that is expected and working. So I just toggled back on. Just do basic blink equals true. Let's run that. Hopefully get back to normal behavior. Yes sir, it worked. See, that's the kind of instant feedback troubleshooting we need. Just to quickly find out what the hell is going on here. Let's run it. Oh, let me show you. My bad. Alright, so for the main while loop, while run program equals true, we were getting some kind of weird error with all of my code able to run in the while loop. So what I just did is I just added 2 closing parentheses to close the main while loop and close the void loop, which is the other main while loop. And then we commented out everything below. So that way we can isolate just this section of code and get it working. Just blink is set to false. And everything should work now. Also I set this to 1 second delay, so it should blink at a 1 second interval. What the hell? It's not blinking. But the status light is on the ATtiny. That's weird. Okay, so what the heck is going on? "5-volt signal coming from solenoid state equals digital read solenoid signal read in pin 2. Seems like it came back as a high flag, which is not what it's supposed to do, I don't think. Is this supposed to have a pull-up resistor to ground or something? Maybe. The other question is, why is it the onboard LED? Oh, that must be LED 1. LED pin 1. What the heck? Four. LED pin 4. That ought to solve it. That will solve it turning on some LED on the board itself, which must be pin 1. Because I don't like seeing that board turn on. Alright, so pin 4 will come on. Void setup is good. Pin 4 needs to be set as an output. Good. And then pin 4 is supposed to turn on if it's high, and it will. But we don't have anything plugged into pin 4, so nothing will happen. That's what we want, nothing to happen. Yep. That's what I want. Stop listening. I'm trying to code my laser printer microcontroller. Troubleshooting. Trying to figure things out. Alright, it worked. Nothing happens. Good. That's what we expected. In fact, I can do this. And I can, okay. So now it will blink on pin 3 whenever it's getting the high signal. So let's run that. It blinked on pin 3 one time. Why is that? Oh, because this runs once. Wait, does it run once? Yeah, stop listening. Yeah, it does run once. Because it would then run the motor sequence thingy. Okay. We're getting somewhere. We learned that we learned that if you output to pin 1, that's also coincides with turning on a LED on the Attiny85, so that's useful information. And we also learned that a default, or that it thinks it's getting a 5-volt signal from the solenoid, which it's not. What if it queried pin 4? Because that's the only pin we're not using right now for the programming. We could have the LED be pin 5. Are we using pin 5 for anything? We could find out here. Pin 4, 2, 3, and 0. Nope, pin 5's unused. So alright. Let's switch our queries to pin 4. The LED pin, we're gonna go with goodness. So pin 4 should stay low until it actually gets a reading. We're already using pin 3 as an LED. Pin 4 as a signal read-in. I guess we could put them back on 1. The LED on the board itself we'll put to work. That'll give us 2 LEDs to play games with. Okay, so pin 3 remained our main output pin that we play with for blinks. Pin 4, and this also kind of tells us that our loop is working. Pin 4 is now our solenoid read-in pin because it's not used. It should default to being low. Pin 1 is output, and it also happens to be an actual LED. Pin 0 is our motor pin, which hasn't changed. Okay. Pin 4, signal read-in, it's blank. Let's hope it's low. Pin 1 is the onboard LED. Pin 3 remain the same. Got it, okay. So what we want to do, basic blink is false. It's going to come in. Historically, it's been reading 5-volt signal coming from solenoid state on pin 4, which is our only blank, and that's good. Pin 4 solenoid state reads in. If it is high, I want you to blink pin 3. If it is low, I want you to blink pin 3. Also, if it's high, go ahead and turn on LED pin 1. Okay, let's run it. Ooh. LED pin 1 did not come on, so that means it's set to low. Interesting. Let's make this blink with a 5-second delay. Oh, by the way, this is what's happening. So it's the 1-second blink, but the LED pin is off on the Attiny right there. You don't see any light, do you? Nope. So coming back to here, we just change this. So if the 5-volt signal is set to low on pin 4, which is completely empty for us, then it's going to have a delayed blink with a 5 count of being on. So that will be a change. Beautiful. Okay. So each time it's going to do that until one of these times it will come back with a different result. Where the signal to be set to high and come back with a different result. Alright. We've learned a lot so far. I don't know how much longer I want to go. I think I have to stop. I have to stop. We had a good session. We're figuring out a lot. We're working our way through getting our code working and tested properly. Little by little, we're working through it. And I think we're getting there. It's a process. Eventually, we'll get there. It's a tough, tough job. Very frustrating. Weird stuff. Weird stuff happened. Like, if you tried to program it... Wait, what even happened? It wasn't programming, and it wasn't programming because... Wait, no, it was programming, but it couldn't run the program if it was connected to Arduino's ground, even when Arduino was shut off. Something weird like that. And then the LED wouldn't turn on. It's just like, what? Some weird stuff. Really weird stuff was going on there. I don't even know. But if we kept everything plugged into the Arduino completely, then it all ran properly. Okay. It's like, yeah. Anyways, guys, peace out.